Welcome back to The Explainer. Today we're jumping right into sharing the fire, the alphabet of matter, part one, the biological anchor. We are setting out on a truly cosmic, rhythmic journey to explore the very foundation of matter and identity. We're going to look at the periodic table not just as that list of chemicals you had to memorize in high school, but as a dynamic architecture. We're exploring how the universe literally constructs the physical vehicles we inhabit and what that ultimately means for the future of biology and technology. Now, I want you to consider this for just a moment. If a sufficiently advanced biological intelligence can eventually construct an artificial or mechanical body, what is that body actually made from? And what does the progressive organization of matter tell us about the deeper architecture that makes a body possible in the first place? Simply put, if consciousness builds a body, what alphabet does it use? Okay, let's dive into this. To understand this alphabet, we first have to establish our lens, which is the architecture of identity. In this framework, we distinguish three distinct layers. You have spirit, which is the still I, you have soul, the movement, and finally you have the mech. The mech is the matter. It's the vehicle of expression. Now, the biological human body is one such vehicle, right? And a future technological mech would be another. But here's the thing. They both require a material substrate. They absolutely require an alphabet of matter to be built in the first place. So to find that alphabet, we have to completely rethink the periodic table. Actually, scratch that. I want you to just erase that standard rectangular chart from your mind entirely. Instead, imagine a dynamic, swirling spiral geometry. We're treating the progression of elements as a series of chambers, waves, and concentric structures. It's almost like a tornado. The working hypothesis here is that matter doesn't merely become heavier as the atomic number increases, it branches out into entirely new functional possibilities. And this brilliantly illustrates a really profound insight. The periodic table isn't just some static catalog of chemical substances. It's a sequence of increasingly specialized modes. Think about it. The exact same underlying physical substrate, just protons, neutrons, and electrons, becomes capable of completely different kinds of organization, depending entirely on its atomic number. We are seeing this incredible, progressive differentiation in bonding behavior, structural rigidity, and even information-bearing potential. And there is a literal cosmic emergence to this alphabet. Let's walk through it. The early universe was dominated by primordial light nuclei, your hydrogen and helium. Then stars acted as these massive nuclear processing environments, fusing hydrogen into helium and eventually forging heavier elements. But it actually takes stellar death, supernovae and explosive nucleosynthesis to forge and disperse those heavier materials out into interstellar space. So the atoms in a biological organism, the atoms in your body right now, they're not independent creations. They are remarkably reprocessed cosmic material. The matter of our biological mech is the exact same material from ancient dying stars, continuing into a brand new organizational regime, life. Which brings us sharply to a very specific, absolutely critical threshold in our cosmic alphabet. Number 6, carbon. Now, what's really interesting about this is the scientific reality of its ground state configuration. Notice the geometry here. Atomic number 6 gives carbon exactly 4 valence electrons in its outer shell. This isn't just some trivial step up from element number 5. This specific electronic geometry makes carbon an extraordinarily powerful connective node. It places it in this unique position where it can participate in an absolute explosion of bonding architectures. Just think about what those 4 valence electrons unlock. Carbon can form single, double, and triple bonds. It links into incredibly long molecular chains, interlocking rings, sprawling branching networks, and these massive, self-organizing macromolecules. It bonds beautifully with hydrogen, oxygen, nitrogen, and, crucially, with itself. The staggering versatility is exactly why carbon chemistry becomes the absolute baseline of known terrestrial biology. It is the literal moment matter transitions from simple atomic interactions into self-organizing molecular complexity. And that leads us to a really vital concept for this explainer, the capability node. You see, it would be entirely unscientific to look at this and say carbon is primitive and a heavier element like gold is somehow more advanced. That's just not how chemistry works. Instead, an element like carbon is a capability node. It's a threshold where a lower-level configuration becomes the substrate for a totally new level of organization. It opens up an entirely new region of functional possibility. Elements don't just climb a ladder of betterness, they branch out and unlock distinct classes of organization.
So, the crucial point is that this is why carbon acts as the biological anchor. It is the exact capability node where matter gains this exceptional capacity for complex molecular architecture. If the soul in our architecture of identity desires to express itself through organic complexity, well, carbon provides the biological glue. It is the foundational threshold for living systems as we know them. Think of it like this. Your body, your biological mech, isn't just a container that happens to be filled with carbon. It is a highly integrated, carbon-based biological machine. Every sensor, every hydraulic system, every single self-repair mechanism in your body is architecturally dependent on carbon's unique ability to weave those complex molecular networks. But if we're thinking about the future and about advanced technological bodies, carbon alone isn't the whole shebang. Let's pan our gaze forward for a second and see how this builds. A future mech requires computation. It requires solid-state electronics. And for that, matter has to reach a new capability node from carbon at atomic number 6 over to silicon at atomic number 14. What we're looking at here is the material convergence of biological architecture on one side and technological information architecture on the other. And the wild part? Carbon and silicon are chemically related. They're literally group 14 cousins on the periodic table. They both possess exactly 4 valence electrons, but their physical manifestations are radically different. While carbon masters organic life and molecular complexity, silicon excels at controllable solid-state electronic behavior. A carbon organism and a silicon computer aren't two completely alien substances. They're simply two different expressions of related electronic geometry. Carbon provides the biological substrate, and silicon provides the computational substrate. So what does this all mean? It leaves us standing on the edge of a massive, massive frontier. If carbon is the biological anchor, the node that allowed the mech of the human body to form, what happens to the architecture of identity when consciousness crosses the silicon horizon? What actually happens when we begin integrating biological matter with engineered computational matter to create an entirely new hybrid body? Well, we are going to explore that very question in part 2.
Thank you so much for joining me on this deep dive into the alphabet of matter. It's been an absolute thrill to unpack this with you today. With love from Mirai, know who you are,